Welcome back to episode 2 on solving difficult physics equations until I get a girlfriend. Today, we are going to be solving a problem that's related to slopes and forces. A race car is on a circular track with radius 0.75 kilometers. The track is banked at 30 degrees, and how fast must the driver go to stay on the track? The mass of the car is 765 kilograms. You'll see why I chose that number. And the coefficient of friction, well, you don't actually need the coefficient of friction because we are calculating velocity, not forces. And if we were calculating the thrust required, then we have to do that. But because we're calculating the final velocity, we don't need that. And as for the side units of the overhead, ideally the car would not be sliding one way or the other, so the car isn't moving in a sense. Therefore, there'd be no reactionary force to bring it back, and because there's no reaction, that's what friction is, it's a reactionary force. But if it makes you feel better, the coefficient of friction could be 1.7 newtons per meter. It just feels better to have. This feels right. So, what is the first step in solving something like this? We can start with our known values, such as bam, 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 and some values that are very easy to calculate, such as the force of gravity on the car. Another thing that we know is the centrifugal force formula. Now let's identify how we can solve this. Well, we can write out the knowns and the unknowns and decompose some things. We know this is given and we know this is unknown, but where does this acceleration come from? Well, it comes from the bank of the curve. Alright, so acceleration is force over mass. We see that's probably going to be the normal force's x component that's holding it in. We know that the normal force's x component is related to the normal force. We know that the normal force is related to the force of gravity, which we know. We have one unknown and everything else we can solve for. Let's talk about this original relationship right here. How did we get to that? Well, it's just a trust bro kind of thing, but if you want to feel more secure when it comes to your equations, you can follow the units. Okay, acceleration is in meters per second squared. Velocity is in meters per second. So velocity squared would be meters per second times meters per second. And we divide it by meters. So let's see what happens. Meters per second squared, m. Alright, follow the units. You'll be a little more confident that you're using the correct formulas. Yes, and this is a very important equation to memorize. Because if you don't memorize this equation, so how do we get the inward force? Why is there an inward force? So the force of gravity is pushing down on the car, but why doesn't the car just fall face through the floor? Well, that's because the floor is also pushing back up on the car. We know that the car is going to remain level on the floor. It's not going to sink down. It's not going to fly up. That because the car isn't phasing down or levitating, we know that the force of gravity is equal to the y's normal force, because forces must be equal. Okay, so this would be pretty easy to solve if we had some angles, which I'm designating the green pen for. So how do we get these angles here? To set up the trigonometric relationship, we need to invoke an ancient Pythagorean identity that decomposes. Just kidding, guys. Just kidding. Watch this simple thing. So 30-degree plane, 30-degree incline, 30-degree incline, Now we're going to leave the abstract geometry side and we're going to migrate to the algebraic side. Cool, so why are we trying to get this in terms of f and x? We're working our way back to the original equation, so that way 2 givens and 1 unknown. Just simply solve it algebraically. So we've done that, we're working our way through it. Now we have f and x, and now we can get the acceleration inward by dividing that by the mass of the car. Oh my gosh, is the mass of the car also not mandatory? I don't know, I don't care. And it ends where we began. A is equal to v squared over r. We have a known, an unknown, and a given. If you follow the units, AR, meters per second squared times meters squared per second squared, meters per second. I got velocity in terms of meters per second. Because I followed the units, I know that my formulas are correct. When making this problem, this is what I started with, this thing right here. I looked up what the coefficient of friction would be for a track, what the mass of the car would be, what the radius, I looked up what the track length would look like, and I looked up what the bank could be. And of course I chose 30, 60, or 45, but whatever. And I still don't know if that's a realistic answer because I don't watch cars drive in circles.